Okay. Good. So hello everyone. Good afternoon also from my side. So basically coming now from the hydrogen production. Now as a next topic maybe how, more on the application side basically, how we can use the hydrogen. My name is Hans-Peter. I am with TECO 2030 and we are a fuel cell manufacturer actually. Fuel cell specific for marine and heavy duty environment. And yeah, I would like to give you some insights in the next 10 to 15 minutes actually about how we can use hydrogen and together with fuel cells to decarbonize the shipping industry actually. Maybe first question, or to start with a question actually, how many ships do you think are operating on the world seas actually?
30,000.
It's a good guess, but actually it's more. It's actually over 100,000 ships which are operating on the world seas. We need to consider also that we have round about 1,500 to 3,000 new built vessels per year actually. The power range, so if you're not talking about how much power does it take, to power a ship actually, it ranges from 1 megawatt for smaller type vessels up to 100 megawatt. So it's definitely, compared to automotive industry where fuel cells are also used, it's in the marine industry we are talking about megawatt range actually, what we need on power output actually to power ships. What we also have to consider, typical ships have a lifetime of 30 years or over 30 years, so they're big assets at the end. So that's what we have in the marine industry. What actually goals, are we having regarding decarbonization? So IMO basically, I think recently announced or adjusted basically. So they are aiming between 20 and 30% greenhouse gas emissions reduction till 2030, then 70 to 80% reduction till 2040, and the target to be a net zero by 2050. We also see that a lot of big ship operators, they have their targets. For example, Maersk announced they want to be net zero by 2040 already. So we see a lot of, let's say, aggressiveness to reach those targets. But of the course, what do we need? So we need zero emission solutions to retrofit existing ships, because as you see with the sheer amount number of vessels and new builds happening right now actually with conventional propulsion systems, so ships which are built and built right now actually will not fulfill those targets in 2030, 2040, 2050, but with 30-year lifetime they will still be operational. And I guess we all agree that, as illustrated on the picture on the bottom right, we cannot throw away the ships basically, how we change our smartphones every year basically. So those are big assets and we need to think about how to retrofit these existing assets to be ready for the future, for zero emission operation. And we believe that fuel cells are actually one way or one pathway towards that, decarbonizing the marine and shipping industry. To give you a little bit also a perspective, so what are we talking about? So on the one side in the marine industry we have new builds, new ships being built. There, the fuel cell system and or other subsystems like hydrogen storage, power electronics, etc. This can be already baked into the design of the ship in an early design stage, so you can allocate space basically for all those, for this equipment which is needed. You can already also foresee in the interfaces to the vessel actually how this new propulsion and power plant basically connects with the network of the ship. And we see a lot of in new ship designs which we're involved in already vessel design types which foresee basically fuel cell and hydrogen in their concept design, so you have space available for that. On the other side, as mentioned, with the sheer amount of ships being out there and 30 years of lifetime basically, we're also looking into ship retrofits, and there definitely the complexity increases because you have first of all a large variety of existing ships. So you have river vessels, short sea shipping, you have ferries, you have cruise vessels, deep sea shipping, tankers. So it's a large variety actually what you need to deal with. You need to basically live with whatever space is available in those ships if you want to install, retrofit those ships and put fuel cells on board there. So you need to live with whatever space is available. And of course, when you do such retrofit projects, the operator of the ship doesn't want to have the ship out of operation because then the ship doesn't make money at the end. So as we see even here though, we can cut ships in half to install fuel cells or whatever equipment is needed. but you don't want to do that on a daily basis because it's cost intensive basically and takes out the ship of operation, which makes the operator not happy. So at the end, what are we bringing to the table from TECO 2030? So we developed actually fuel cell stacks and the fuel cell system specifically for the marine environment. We have a 400 kilowatt modular fuel cell solution, where the idea is then you use multiples of those 400 kilowatt modules to reach whatever power output you require. We also offer basically containerized solution, which are then basically the fuel cell with power electronics, etc., is packaged in one container. And these containers can be used for land-based applications, theoretically. You can install those containers, as we will see later on. I will show you one of our example projects, what we are working on currently. You also can use these containerized solutions to install on board of ships, actually. But of course, the fuel cell can also be installed, in a machine room or wherever. In parallel, to that, we're also looking into providing stacks potentially for the automotive industry. But main focus at the moment for us is definitely the marine fuel cell. When it comes to the fuel, actually, which is an important topic, we try to be agnostic and flexible. So fuel and storage, on the one side, we know at the moment there's compressed hydrogen. A lot of the pilot projects we do are with compressed hydrogen. Even from a density point of view, it's not ideal, but it's available. Of course, future also liquid hydrogen, cryogenic tanks, liquid organic carriers, actually. But more important, actually, at the end, on the top right, what you see also to be agnostic for ammonia and methanol, because we see, especially in the marine industry, ammonia and methanol both basically as a good carrier for hydrogen, together with a reformer and cracker technology, where you basically get the hydrogen molecule out of the ammonia or methanol. It could be then also fed into the fuel cell, which is, in a lot of these projects, we see those movements now at the moment, because on the let's say hydrogen production side, what we saw in some of the speeches before, there's still quite something to catch up to have the hydrogen at the end available to fuel the fuel cells at the end. One of our projects, what we are doing or we are working on is basically a project which we do together with Shell, where we retrofit one of their chemical tankers, which they have under charter. It's the vessel is called Bitflower, which was built 2003 with 6,300 deadweight tonnage. So it's not a small ship anymore. So it's like a sizable ship. And our approach is there actually. We will install on deck, actually. That's the advantage of those product tankers, that you have deck space available. So we install a 2.4 megawatt containerized fuel cell power generator in a 40-foot ISO container on deck. It will have basically 6 of our 400 kilowatt fuel cell modules, together with hydrogen gas conditioning, the air filtering system, so the complete power electronics and power equipment is installed in this container to basically connect at the end the fuel cell with the main grid or the power grid of the vessel. So that as a first step, basically the auxiliaries, so the vessel currently has a 2-stroke main engine for main propulsion and 2 4-stroke diesel engines for port operation, so to run basically all the loads when in port to do the loading and unloading of the cargo. And as a first step, so the fuel cell will be connected to the main grid of the vessel, which allows basically then the operator to do zero emission port operation, actually. And this is what we see in the marine now, maybe as the first step, because in ports, we see the regulatories now. I think in California, they have those regulatories already active already, that you should do or have to do zero emission port operation. You're not allowed to run your diesel generators when in the port. So this is a perfect use case, actually, and also gives them the flexibility on the one side. They still have, let's say, the main diesel engine for the main propulsion, but with the fuel cell there, they can also partially do the propulsion with the fuel cell already. So it's then basically at the end, the fuel cell will be installed end of next year. The first test runs are then for end next year, beginning of 2025, with the target of 55% greenhouse gas reduction during voyage. So you can do part of the main propulsion also with the fuel cell. So we also want to demonstrate you not only can do auxiliary power generation on board of ships with fuel cells, you also can do main propulsion with it. You can do 100% or have 100% greenhouse gas reduction in ports, which is important because we know, yeah, ports close to big cities, that's where we need to, yeah, I guess, have the higher need to control the emissions there. So you can do zero emission port operation. And overall, the target is to demonstrate a 65% emission reduction annually. And of course, we, as a technology provider of the fuel cell, out of that project, we are trying to or develop basically standardized solutions, with our fuel cell, containerized solutions to have basically a toolbox ready or a kit ready basically for retrofit existing ships. So that's what we are doing there. What else are we doing? I mean, we provide stacks for also fuel cell demonstrator trucks or pilot projects. That's what we do. Our first project, maybe deviating a little bit from the marine, is actually a land-based containerized fuel cell generator, which is used basically to charge and power electric construction equipment. Also makes sense from us. So basically, we have the fuel cell developed now. We do the first demonstrator land-based, and then the next one, what I just showed before actually, is then end of next year. So land-based demonstration is middle of next year, and end of next year we then have the first installation on board of ships, or of a ship actually. So this is what we are doing mainly of the projects in Europe. So on the US side, we get quite some interest actually from the ports, or are in discussions with some ports for shore power. And I just want to give you here an idea. We are also working on a concept actually where, yeah, you use a containerized fuel cell to put it in the port basically to produce the electricity there, so that basically zero, or you can do zero emission port operations, shore power basically. So simplified, maybe you say like, okay, in that project I showed before with Shell, we put the fuel cell in a container on board of the vessel, but theoretically you can also put the fuel cell in a container in the port to provide basically the electricity from there. And yeah, we see a lot of interest actually from vessel operators, but we also see the hesitation basically of, doing really the investment at the end to make such a project reality. So yeah, with that being said, yeah, thanks for your attention. Thanks for having me here. And if you have further questions, please also visit us at our booth. We're at the far left corner out there. And also, maybe the course, or if somebody is interested in really working together of doing a pilot project, a demonstrator, we are open for that. Also, we are doing projects in Europe, but we are definitely looking forward to do some pilot and demonstrator projects now also in the US. With that being said, yeah, thank you very much. And I think we have some time for some questions.
Thanks for the presentation. So one question on refueling. So you showed in that example where you can just remove the containers and just kind of refuel that way. That's a great way to get started. Do you view that as a potential long-term strategy as well? Or maybe you can just talk about refueling challenges.
I see that's more or less the, let me switch back there. That's more or less the solution what we have now. Actually, long-term, it's definitely more the refueling. But if in order to refuel the ship in the port, you need to have the refueling infrastructure in the port. And this is more or less, I would say, like the quick fix. It's a neat idea, actually, to just swap the containers. So you don't need to have then a bunkering station and refueling station in the port. But long-term, I definitely see the refueling, actually. But you need infrastructure for that as well. So we're actually happy. Even you can argue if compressed hydrogen from power density, it's not ideal, that's clear. But at least it's available. There are containerized solutions available. They are certified also for marine use. Those are the things at the moment, we are looking to start doing projects actually, because otherwise it's a little bit always the chicken-egg problem. What we discussed. Okay, we need more hydrogen, and I guess on the hydrogen supply side, they try to figure out, okay, how much hydrogen do we need to produce? Where's the demand at the end? I think we are,
Thank you.
Yeah.